Hi, Year 10. So, on Friday there we looked at whenever we have two simultaneous equations, then one way that we can solve those is to draw the lines of the two equations and see where they meet. Because the point that they meet at, that's going to give you a set of coordinates like an x value and a y value that satisfy both equations. So that just means both equations will work with that one number. So if I look at this yellow line, if I was to substitute in the x coordinate and the y coordinate like for this point here, yep, it'll work for the yellow line equation, but it won't work for the green line equation because it's not on the green line. So there's only that one point which appears on both lines. So whenever we're asked to solve simultaneous equations, it means find a value for, and I'm just using x and y here, it can be any letters, but find a value for x and y that will work for both equations. So drawing out the graphs and seeing where they cross, that's one way that you can do it. But today we're going to look at a different way that means that we don't have to draw out the graphs. So if you open your notes for me at page 66, please. Okay, so with this example here, we've been given two equations and we're told they're simultaneous equations, and that means that there will be an x and y value that will work for both of them, and we're being asked to solve them. So that means we have to find the x and the y value that will work for both of them. Now, there's a couple of different ways that you can do this, but I'm going to teach you just this one way here now. It might seem a bit random at the start, but once you get into the swing of it, it will work, okay? And you'll get into the habit of it and hopefully start to find them quite enjoyable to do. So the first thing we do is we just name the equations like 1 and 2. So I'm going to call this first one equation 1 and this second one equation 2. So if you label yours for me there as well, please. Okay. Now, we're always going to be adding or subtracting these two equations together, okay? And the whole point of doing that is so that we can eliminate one of the terms. So the simultaneous equations like this, you might also hear people referring to them as two equations, two unknowns, because we've got two equations and we've got two unknown values. We don't know the value of x and we don't know the value of y, and they appear in both of the equations. So if we can manipulate these equations in such a way that we can get rid of one of the terms, then we're down to a bog standard equation with just one unknown, and we all know how to solve those. Okay, so see if I look here, I suppose the aim of the game to get rid of one of these terms is to get to the stage where you have the same amount of either the x's or the y's or whatever the letter is in the question. So see if I look here, 5x plus 4y equals 8, and then I've got 3x plus 4y equals 4. We already have the same number of y's in this, so I don't need to manipulate this one. So this one's sort of starting us off gently. But we're going to carry out the same technique that we would do if we were having to manipulate them, okay? So start off, I'm just going to write out equation 1, which is 5x plus 4y equals 8. And directly underneath it, I'm going to write out equation 2, which is 3x plus 4y equals 4. Now, I'm going to draw a line underneath here, the same way like as if you were taking away numbers or adding numbers that you would write it. And I have to decide whether I'm going to be adding or subtracting here. So let's think it through. If I was to add this, I would get 8x plus 8y equals 12. Well, that hasn't got rid of anything. So let's see about subtracting. If I was to subtract like the bottom equation from the top equation, I would get 5x take away 3x gives me 2x. 4y take away 4y gives me 0y, and that's what I'm looking for, to get rid of those, and then that's going to work. Okay, so I always write in big massive letters, either subtract or add. And the reason that I write it in big capitals like that is because sometimes you're adding and sometimes you're subtracting, and it's so easy to like forget halfway through what one you're doing and accidentally do the wrong one. So if we have it written there, then all we have to do is glance over. Now, be super careful that you're always consistent. So I always take the bottom equation away from the top equation. So 5x take away 3x gives me 2x. 4y take away 4y gives me 0y, so I don't write anything there, equals, and then 8 take away 4 gives me 4. So now we have 2x equals 4, which is just a normal equation that we know how to solve. So let's solve it. To get x on its own, I have to divide both sides of my equation by 2. So 2x equals 4, divide by 2 gives me x equals 2. So now I have one of the values, or one of my unknowns. So this here is part of my answer, it's not my whole answer. I also have to find the value of y. So to do that, I take my value of x that I've just figured out and I substitute it into one of these equations. It does not matter which. I generally just try and pick whichever one is going to be easiest for me. So these two are much of a muchness, doesn't matter. I'm just going to substitute it into equation 1. Okay, so substitute into 1. So equation 1 is 5x plus 4y equals 8. And all I have to do is substitute for x here, because I now know that x has the value of 2. So 5, replace that with a 2, plus 4y equals 8. Okay, so 5 multiplied by 2 is 10, plus 4y equals 8. Now we have to solve for y. So y is getting multiplied by 4 here, and 10 is getting added on, and we need to work in the reverse of that. So we need to take 10 away from both sides. So 10 plus 4y, take away 10, just leaves me with 4y there. 8 take away 10 gives me minus 2. Okay, to get y on its own, divide by 4, because it's currently getting multiplied by 4. So divide by 4. So y equals minus 2 divided by 4 is minus a half, or minus 0.5. So that's both my solutions. So if I was writing my answer for this, I would write x equals 2 and y equals minus 0.5. Now, what we should do then is check by substituting into the other equation. I'm not going to write it out, but I'm going to do it like in my head. So see the way we found y by substituting into 1? Let's have a look at equation 2 and see if putting x equals 2 and y is minus 0.5 into this equation works. So 3x, 3 times 2 is 6, plus 4 multiplied by minus a half. 4 multiplied by minus a half is minus 2. 6 take away 2 gives me 4. Happy days, it works. Now, as I say, that method might seem a little bit strange, but the more we practice it, the more familiar we'll get with it, and the more it will start to come naturally. So let's look at another example. Over on page 67, example 2. So same again, we start by numbering our equations. So let's call this one equation 1 and this one equation 2. Now remember, we're trying to get rid of one of our terms. So we've got 5a and a, not the same. We've got 4b and minus b, not the same as each other. So we're going to have to manipulate one of our equations to make it be the same. So let's have a wee think about that. Well, see if I was to multiply through this equation by 5, that's going to give me 5a minus 5b equals 20. And then I'll have the same numbers of a's, and then I'll be able to get rid of that. Another option is that I could multiply through by 4, because that would give me 4b and minus 4b, so I could get to 0 that way. I could get to 0 b's that way. So either one would work. I'm going to go with multiplying by 5 for this one, okay? But we could have easily done it the other way. So equation 1, we're leaving it as it is, so we're just writing it. 5a plus 4b equals 8. Equation 2, well, we're going to be changing that because we want to get the number of a's to be the same. So equation 2 multiplied by 5. Now, remember to multiply through the whole thing by 5, not just part of it, not just the left hand side, not just the a's, the whole thing. So a multiplied by 5 gives me 5a, minus b multiplied by 5 gives me minus 5b, equals 4 multiplied by 5 gives me 20. Okay, so we'll draw our line under. Now we'll have to decide whether we're adding or subtracting. So to get rid of these a's, because the one that we get the same number of, we're trying to get rid of it. If I add, I'm going to end up with 10a. That's not going to be any use to me. So again, I'm going to be subtracting in this one. So I write it here. Okay, so 5a, take away 5a, just leaves me with no a's, nothing. Now be careful, look, 4b take away minus 5b. Well, that's the same as 4b plus 5b, so that gives me 9b. And then 8 take away 20 gives me minus 12. Okay, make sure you're happy enough with that, because there's so many rooms for, like, so much room for wee mistakes to happen there. So 4b take away minus 5b is the same as, I'll write it out over here, 4b take away minus 5b is the same as 4b plus 5b, gives me 9b. And then another wee common mistake here is that people will think that this isn't allowed to be a negative. It is. So remember, we're always taking the bottom equation away from the top one, so don't suddenly turn around and do 20 take away 8 here. Make sure you do top number take away bottom number. Okay, so we've got 9b equals minus 12. To get b on its own, we're going to have to divide by 9. So draw lines down both sides. Divide by 9. So 9b divided by 9 just leaves me with b. Now see, with ones like this, I would probably write this just as a fraction first and then try and figure it out. So it's minus 12 divided by 9. So if I simplify that fraction wise, 3 will go into both of these. So minus 4 over 3. So I could rewrite that as minus 1 1/3. Okay. So now we've found b. All we'll have to do now is find a. I've taken up far too much room here. So we'll do it down here. So we've got b, we have to substitute that into one of our equations. So let's have a wee look and see either this one or this one. I reckon equation 2 is going to be easier this time, just because there's less multiplying and stuff to do. So substitute into equation 2. So a minus b equals 4. So a minus, careful, minus 1 1/3 equals 4. So I would rewrite this to save me from making a silly mistake. A minus minus is the same as a plus 1 1/3. So to get a on its own, I need to take away 1 1/3 from both sides. Oh, wrote that wrong. So that leaves me with a equals 4 take away 1 1/3. What's that going to be? 2 2/3? Yeah. Okay. So here's my final answer for this one. Remember, final answers will always be the two things, the two letters, so something and something else. Right, example 3. So let's have a little look at this one. So first of all, number our equations 1 and 2. Let's have a look at them. 5x plus y equals 22. 2x minus 5y equals 25. So see, if I look at my x's, can I easily get them to be the same number? Or like to have the same number in each equation? Probably, but you know what, because 2 doesn't go into 5 nicely, or 5 doesn't go into 2 nicely, we're going to end up having to multiply both equations there. So let's see if we can get away without doing that. So let's look at the y's. We've got 1y here, and then we've got minus 5y here. So if I multiply this top equation by 5, then I'm going to have 5y here, and I'll have minus 5y here. So I am able to get the same number of 5's. So that's what I'm going to do. I'm going to take my first equation and multiply it by 5. And remember, the whole point of this is to get the same number as one of the letters. So for this one, we're trying to get the same number of y's. So I'm taking equation 1 and I'm multiplying by 5. So 5x multiplied by 5 is 25x plus y, which has to be multiplied by 5, is plus 5y. And then 22 multiplied by 5 is 110. Okay, underneath it, we're going to write out equation 2. We don't have to change it, so we're just writing it and lining up our terms. So 2x minus 5y equals 25. Right, let's decide if we're adding or subtracting. So we look at the number that we're getting rid of here, and it's going to, or the letter that we're getting rid of, and it's the y's. So if I was to subtract this, I would have 5y take away minus y, which would be like 5y plus y. So that's going to end up giving me 10y, so that's no use. So if I was to add these two this time, so this is slightly different from our previous two examples. If I was to add them, then I'll end up with 0y, because 5 plus minus 5 is the same as 5 take away 5, and I end up back at 0. So this time we're adding. Okay, so 25x plus 2x gives me 27x. 5y plus minus 5y gives me 0y, so don't write it. And then 110 plus 25 gives me 135. Okay, to get x on its own, I have to divide both sides by 27. I would probably allow you to use a calculator for this. What does that get me? 5. So we've got one of them, x is 5. So now we take that and we substitute it into either equation 1 or equation 2. I would probably choose equation 1 in this one just because it's all positives, there's no negatives. And negatives can lead to silly mistakes quite often. So substitute into equation 1. So equation 1 is 5x plus y equals 22. So 5x is 5 plus y equals 22. So that's 25 plus y equals 22. Get y on its own, take away 25 from both sides. So I'm just left with y there. 22 take away 25 is minus 3. So that gives me that. So my answer here is x equals 5 and y equals minus 3. So you're going to do some questions like these. I appreciate that this is brand new to you, so please make sure you ask for help. If you're stuck, I will be able to help you out. But see, before we start, if we have a little look back over our examples, there's a little sneaky rule that we can do to decide whether we're adding or subtracting. Okay, see if you look at the term that you're eliminating, so the letter that you're getting rid of. So for example, in this one, it was the A's. Do you see how the sign of both of those was the same and we subtracted? Let's look at the first example. With this one here, we were getting rid of the y's. The sign was the same, so they were both positive. We subtracted. In our third example, let's see here, we were getting rid of our y's. Our sign was different. One was positive and one was negative, so we added. Now, I'm not really a fan of little rules like this because I remember them wrong or something like that. So I prefer just to think it through logically. But if you can remember little rules like that, then this is helpful. So we'll make a wee note of that here. Okay, so write that in for me. If the signs of the term we're eliminating are the same, then we subtract. There's a good wee way you could remember it. Same, subtract. They both start with S. Signs are different, add. Don't have anything to any sneak away for that, but I suppose if you remember that one, same, subtract. Okay, I'm going to give you some questions to do here. Let's have a little look at them before I just drop you in the deep end. Okay, so you're going to be doing exercise 10A. The questions start on page 199. So in this one here, look, we've got 2y and y. I would multiply the second equation by 2, and then you're going to be subtracting. So I'm trying to give you some little hints here to get started. In this one, I would multiply the second one by 4, and then because that's going to be minus 4y and that'll be plus 4y, signs are different, you'll end up adding these ones together. Okay, oh no, not all of them. Let's have a wee look at this one. See here, we've got minus 4y and we've got plus 2y. Oh, our x's are quite awkward to get to be the same number, so I would eliminate the y's there by multiplying this bottom one by 2, the whole equation. And then this one here, I would multiply the whole equation through by 4. Don't know if I'm giving you too many hints here. I didn't tell you 3 or 4, I'll let you do those ones. Down at the bottom then, let's have a wee think about these ones. Again, here, I would probably multiply through by 2 because that's going to give you 6y, which matches with that. So you're just trying to match one of them. Here, I would probably multiply, again, top one through by 2. Because then you're going to end up with 4x here, and that'll get rid of those. Same here, I would get rid of the x's in this one. I would multiply through by 4. I'll let you have a wee think about the rest of them yourself without giving you too many hints. But I am expecting you to find this difficult, particularly at the start. So do make sure that you send me a wee message and ask for help if you need it, okay? Don't be sitting there not knowing what to do. I'm here to help you. Okay, I'll see you tomorrow.